Welcome to Let's Talk Cabling, your gateway to the world of ICT. Get ready to dive deep into knowledge that
Hello and welcome to Let's Talk Cabling. I am not Chuck Bowser, as you probably have already figured out. Chuck pinged me today and asked me to cover for him. He had to have emergency oral surgery, so I am going to be presenting this evening. My name is Steve Cowles, and I am with AEM. And Chuck and I are pretty good friends. We hung out a little bit at Bixie last week. And so he pinged me today and asked me if I could fill in. So welcome to this episode of Let's Talk Cabling. We're going to be talking about extended distance cabling tonight. That was a hot topic at Bixie last week. Before we do that, just to keep with tradition, what's everyone drinking? Go ahead and put your answers in the chat there. And I'm drinking water tonight in my big stainless steel cup, so you may see that from time to time. And while we're looking at some of those answers to come in on what you're drinking, let's throw an acronym out there. Chuck likes to put acronyms out there, and this one will kind of relate to what we're talking about tonight. The acronym is DCRU. So go ahead and chime in the chat and let us know what DCRU is. And we will go ahead and bring out some answers there, and then nobody comes up with it, we'll give the answer shortly. So, and Chuck, I know you're with me in the background, so if you see an answer pop up that I don't see in the regular live chat, just let me know. And one thing I will show you, Chuck presented this to me last week at Bixie. I have my very own Let's Talk Cabling Challenge coin, and on the back, it is numbered. Number 8 out of a limited 25. Knowledge is power. Appreciate that, Chuck. So if you're interested in how people got those, or a few people that got those last week, supporters of Let's Talk Cabling, if you support in a certain amount, even over time, Chuck has these coins that he gives out. They're in a limited quantity right now. There'll probably be another run of them at some point, but this is the first run. So thanks again, Chuck, for that coin. And again, please put your answers in the chat for DCRU. So what is DCRU? Don't see any answers yet. While we're waiting for some answers there, I'm going to go ahead and start talking a little bit about extended distance cabling. So we all know about the standards. The NCTA standards, and we know that there's a 100-meter limit for the channel, 90 meters for the permanent link. But there are certain situations where we sometimes have to go beyond that distance. A one-off, a device that's in a place where we can't reach it with 100 meters of cable, and running fiber is not feasible. It's not feasible to put in another TR. So manufacturers have developed cabling to support these extended distances, to go beyond 100 meters. Ethernet technology early on, 100 meters was pretty much it, and that's kind of what started that 100 meters, because you'd start to get collisions beyond that. But now the technology's improved. The network equipment on either end can compensate for a lot. And with differences in cabling construction, we're able to stretch that distance a little further. And some manufacturers of 4-pair cabling have come out with these different cables that will actually allow us to go a little further. Typically, they're going to have a heavier gauge to get you a little lower resistance and be able to go those additional distances. And some of them will go as much as 150 to 200 meters. And there are several quality manufacturers that have these cables. Now, there are some considerations when we start looking at these longer cables, things we need to keep in mind. The DC resistance is key, especially if we're going to run power over Ethernet. And this is where the DCRU comes in. And somebody said data communications room unit. No, it's not data communications room unit. It's actually DC resistance unbalance. So we've heard of loop resistance, DC loop resistance, and DC loop resistance is a measurement of that resistance of the pair, round trip resistance of the pair. So that's DC loop resistance, and then DC resistance unbalance is the measurement of there's two different measurements for DC resistance unbalance. One is DC resistance unbalance in the pair, where we look at the DC resistance of each conductor in the pair and compare them. And then the other one is DC resistance unbalance pair to pair. And the pair to pair compares the DC resistance unbalance of one pair to all other pairs. And you do that in every possible combination between the pairs. So that is DC resistance unbalance. It's an optional test under the standards. So recently the NCTIA 568.2-E made it a required measurement on the cabling manufacturer. So on the specification side, it's in the required measurements. For the field testing, which is covered by NCTIA 1152A, that's currently an optional test. So DC resistance unbalance is optional. However, it is highly recommended that you do a DC resistance unbalance test when you're testing cable that's going to be deployed for power over Ethernet, because if the resistance is in an unbalanced state on those cables, you will have problems with your power over Ethernet. And you know, especially when you get into the high power PoE where you're doing 90 watts on all four pairs, if those pairs aren't balanced, the power is not going to be balanced across the pairs. You'll start to see problems with the electronics on either end. So it's important to make sure you test that. Now, how do you test that? If you want to test DC resistance unbalance, consult the user manual for your particular certification tester, and you'll change the limit. So you're going to go in where your limit is set for an ANSI TIA limit. Instead of choosing a Cat 6A permanent link limit, for example, you would choose a Cat 6A permanent link plus. On our tester, on other testers, it might be plus PoE, but that would be the limit. So consult the test equipment manufacturers and find out which limit you should use in order to test that. And that's important whether you're using extended distance cabling or, pardon me, or your regular Cat 6A or Cat 6. You want to make sure that if it's going to be used for PoE, you do a DC resistance unbalance test. So again, with the extended distance cabling, these manufacturers are building these cables to allow us to go a little further. Now, it's outside the scope of the standards, granted, but there are going to be exceptions. There are going to be situations where you may need to use a cable like this. And when they manufacture these cables, they're typically going to be manufactured of a little heavier gauge, like a 22 gauge, for example, as compared to a 23 gauge for our typical Cat 6A. That gives you a lower resistance over the distance, so that's going to help. And what the manufacturers will do is they test these at different network speeds. And they look at the performance of the cable at different lengths and different speeds. They will do things like a bit error rate test and a signal to noise ratio test on these cables that are performing well at certain distances on certain speeds. And they also do the physical RF cable test we know as certification. And they look at all these results and they determine, okay, we can run X amount of feet for 1 gig or X amount of feet for 2.5 gig. And they'll rate the cable for what it can run. And they will also develop test limits based around this performance. And this is important to understand because if you're testing an extended distance cable, you want to make sure that you use the limit designed for that manufacturer's extended distance cable. If you use an ISO limit or an ANSI TIA limit, like a 568.2-E Cat 6A limit for permanent link, and you test the extended distance cabling and it's over 100 meters, let's say it's 150 or 160 meters, it's going to fail length. That's just part of that ANSI TIA measurement. You know, length is a requirement, and it's pass fail at 100 meters for a channel, 90 meters for permanent length. So it will fail if it's too long. It can also fail if it's got excessive delay and you're using that limit. So when the manufacturers develop these cables, they look at the delay, they look at the insertion loss, the return loss, and all these parameters when it's performing well, and that's how they create their limit. They basically take an IEEE limit for that network speed, and they look at that, and then they build their limit based on the cable performance and what the tests look like on the cable that's performing well. Now, another thing to keep in mind when we're talking about extended distance cabling is that not all Ethernet equipment is created equal. Your switches, your devices, there's a physical layer chip in there, the Ethernet PHY, and that Ethernet PHY is going to be different on different manufacturers, and some Ethernet PHY may handle that extended distance better than others. One of the big considerations we mentioned, insertion loss. Of course, crosstalk is going to be key, but return loss comes into play as well. So if you've got excessive insertion loss on a cable that's longer than standards, on an extended distance cable, and then when you install it, for whatever reason, you have return loss problems. Now, return loss, it's essentially reflected signal. So insertion loss is how much signal we lose traveling down the cable. Return loss is how much signal we're losing based on a reflected signal. That reflection, that return loss reflection, is caused sometimes by an impedance mismatch between hardware and the cabling, or connectors into another piece of hardware, like a jack on a panel and a plug going into that. If there's any kind of mismatch there, we can see return loss reflections. And there's always going to be some return loss. So we're going to lose some of that on the cable. Some of those PHYs, and I bring up the return loss because that goes back to what I was talking about the Ethernet equipment. Some of those Ethernet PHYs will handle that better. They have better correction algorithm in them, and they can handle more return loss. Others can't. So while it may perform well for one particular brand of Ethernet equipment, maybe another one it doesn't perform so well. So it's important to understand that as well. The manufacturers all try to do their due diligence when they create these cables, though, to make sure that they'll work with as wide a variety as possible. And I believe they build in a little bit of buffer. They know it may perform better than what they rate it for or go a further distance, but they're probably going to be conservative. And give you a rating that they know for sure, even if there's a questionable PHY, they should perform well with it. So that brings up another important point, and I talked about the return loss, and the terminations, the jacks, the panels. If you're going to use this extended distance cabling on a job, speak with the manufacturer of the extended distance cabling. Find out from them what particular termination hardware works best with their equipment. So find out the brand of jacks and panels. If they don't manufacture all of it, they've teamed up with somebody to make sure that they can get the optimal performance on that. So make sure that you're installing the correct jacks. You don't want to just take a good quality extended distance cable that you need for an application and install it and go buy the cheapest termination hardware that you can put on it. That's not the right way to do things anyway, but certainly when you're trying to eke out more distance from your application, you want to make sure you give yourself every benefit possible, and by making sure that you're using termination hardware and cabling that's optimized to work together, you'll make sure that you get that performance all the way to the end of that link. Now, pardon me, these extended distance cables will also typically support power. PoE, power over Ethernet. And again, that comes back to the resistance, because they've designed it with a heavier wire gauge. It's going to have a lower resistance. So you'll be able to get that PoE load, that power from one end to the other, typically without a problem. And you can consult the manufacturer to find out what it will work with. So make sure that they can support, and they'll tell you that it can support a certain amount to the end of the link. They'll tell you how much it will support. So again, consult with them. So yeah, I see some stuff coming in here. People notice that Chuck's not here. They're saying hi. I haven't seen anybody tell me what they're drinking yet tonight. So again, I'm drinking water. Um, Tyler said, thanks for filling in. Glad to do it. Chuck and I are good friends, and he reached out, and I was more than willing to help. So, and the topic tonight, we're talking about the extended distance cabling. It was a hot topic last week at Bixie. A lot of discussions about it last week. And good to see a lot of familiar faces out there last week. So, again, back to that DC resistance. The heavier gauge cable that these manufacturers make will give you a lower resistance over distance. So, 22 gauge has a lower resistance than a 23 gauge. So we want to make sure that that we don't have too much resistance. So somebody said, well, listening to this, I'm reading, and they have a customer that says they do not want PoE extenders. Well, there you go. So in this case, depending on what distance you're running, you may want to consider the extended distance cabling. Again, these manufacturers can go, depending on who they are, you can talk to them. They can tell you what they'll support and what distance, and you can go, in a lot of cases, 150, 200 meters and probably still do your PoE at that distance. And some of it will depend on what PoE you're running, those kind of things. And this kind of brings us into a segue into another extended distance technology. Somebody just said we're feeding parking lot cameras with long distance Cat 6. Great. So there is another long distance technology that's not 4-pair that was talked about quite a bit at Bixie last week as well. In fact, there were a couple of speaking sessions on it, and that is single pair Ethernet. Now, many of you have probably heard about single pair Ethernet. You may not know what it is, but essentially it's just like what it sounds like. It's a single pair. It's 2 conductors that's going to run Ethernet. Now, it's low speed, low bandwidth. It's going to be 10 megabits per second. However, you can go 1,000 meters, 3,280 feet on single pair Ethernet. So, single pair Ethernet out to 1,000 meters. Now, that's on an 18 gauge pair. And then if you're using 23 gauge, you can go out to 400 meters. Now, again, it's low bandwidth. It's designed it's not going to replace our regular ICT networks. It doesn't replace those. It is designed to offload low bandwidth devices from those main networks. Things like cameras that only require a 10 meg connection, an occupancy sensor, access control device. Those type of low bandwidth devices can be offloaded to single pair Ethernet. Now it's going to use different connectors. There's the connector that seems to be the dominant one for our industry is called the copper LC. It looks physically like I wish I had one. I should have thought to have one here with me, but it looks physically like a fiber LC connector. It's about the same size. It's even got the same type of clip on it, but it's a copper connector, and it's designed for single pair. So you can get some high density with that. And then, so again, you can run 400 meters on an 18 gauge. You can run 400 meters on 23 gauge, 1,000 meters on that 18 gauge, and it will carry power. Now, the power considerations are going to be a little different. And I'm going to have to pull up some notes here so I make sure I don't misspeak on the power. But when it comes to the power, we're looking at 1,000 meters on an 18 gauge. We can get 7.7 watts of power. So there's quite a few cameras that will run on 7.7 watts of power. Some won't. If you've got one that has heating elements and all those kind of things, in a winter environment, it's probably not going to run on 7.7 watts. But that's at 1,000 meters. Same 18 gauge at 445 meters, which is 1,460 feet, you're going to be able to push 20 watts on that. Now, this is assuming the resistance is within spec, so 25 ohms of resistance on that 445 meters. We go down to 187 meters on an 18 gauge, 1 pair, single pair Ethernet. You can do 52 watts. That's quite a bit of power at almost 200 meters. So so you do have that capability with single pair Ethernet. Now, if we shift down to the 23 gauge, 400 meters, you're going to get that 7.7 watts. You can get 20 watts out at 145 meters, and then you can get 52 watts out at 58 meters. So, yeah, in that case, if you need more power, you may be better off in that instance with a 4-pair or going to that 18 gauge instead of the 23. If you really need to push that power. So that's where single pair Ethernet comes in. Again, it's another extended distance technology. The difference between single pair Ethernet and the now somebody asked, is this Game Changer you're speaking of? No, actually, Game Changer is one of the extended distance cables. Single pair Ethernet is different. The 4-pair extended distance cables I was talking about in the beginning, Game Changer is one of them. There's several other manufacturers out there that make those 4-pair extended distance cables. And again, those cables are not recognized by the standards. But we all know that you've got to have some exceptions sometimes because you need to do something on a job. You may have to do something that's a little outside the scope of the standards. The single pair Ethernet is different. Single pair Ethernet is covered by the standards. There are standards for single pair Ethernet. So, single pair Ethernet is covered under ANSI TIA 568.5. That's the cabling components. The 568.7 covers the industrial cabling components, and then the ANSI TIA 5071 covers single pair Ethernet cabling field testing. So those are all published standards. There's also a TSB 184-A-2, which covers the power delivery over single twisted pair cabling. So those single pair is covered by the standards. The 4-pair extended distance cablings are not. Will they be at some point? Possibly. Who knows? My experience, and Chuck and I have been doing this about the same amount of time. I got in the industry in the mid 80s. Standards develop around needs, and the standards are one thing. Technology advances, and there's a need to be filled. It's addressed by the technology, and at some point the standards change to adopt new technology. So, in my opinion, and this is just my opinion, I think at some point we will see the 4-pair extended distance cabling in the standards. So I think we're going to see this at some point. So that's that is single pair Ethernet. Now, what about testing it? When it comes to testing, we talked about testing the extended distance 4-pair cabling, and you have to use the manufacturer limit, and of course you want to make sure you set the cable to the right cable type so your NVP is correct. And but when it comes to single pair Ethernet, what do we do? So check with your test equipment manufacturer first to see if they have a solution. The company I work for has a solution. It's a test adapter for our tester. But the thing with testing single pair Ethernet is it's tested at a much lower frequency than what we do for regular 4-pair. Regular 4-pair cabling is tested down at the bottom end. I'm going to double check my numbers here. It is tested at, I believe, 1 megahertz at the bottom end. Just let me double check. I've got a note here where, yes, it's so it's 1 megahertz down at the bottom end, whereas the single pair Ethernet, you have to go all the way down to 0.1 megahertz. So we have to go much lower on the single pair Ethernet in order to test. The other thing is that single pair Ethernet needs to be tested at finer frequency resolution. And what that means is we have more test points along the frequency spectrum because it's a much longer cable. In order to identify faults on the cable, we need to take these measurements at tighter frequency points along that frequency spectrum. So from that 0.1 megahertz, up beyond 10 megahertz, almost into the 100 megahertz range, we're testing at a 20 kilohertz interval, whereas when you look at 4-pair cabling, we're testing at 150 kilohertz interval. So there's a difference. So and that test will take longer. It's not going to be a 6-second Cat6a auto test. It's going to take longer to run a single pair Ethernet test because you're testing more data points. So there's a lot more data points to gather because you want to make sure you can find those faults on that longer cable. And so there is that. So again, consult with your test equipment manufacturer to find out if their equipment will do SPE or what their solution will be. I think every equipment manufacturer is going to have a solution at some point. The other thing when it comes to testing, we're not testing as many different things on single pair Ethernet as we do on our 4-pair. We're testing insertion loss, return loss. On unshielded cable, we test TCL, which is a measurement of balance and noise, the ability of the cable to resist noise. We test DC loop resistance, and we test delay on single pair Ethernet. So those are the things that are typically tested. DC resistance unbalance that we talked about earlier on the 4-pair cabling is the only cables you can really do unbalance measurement on single pair is going to be a shielded, because you have to use the shield for reference. So you can't test unshielded single pair for unbalance, but you could test a shielded single pair. Unbalance isn't as critical when it comes to single pair Ethernet as compared to 4-pair cabling, where that unbalance, especially between pairs, is going to create a much bigger issue. So when it comes to single pair, it's not as critical. But again, as I mentioned earlier, if you're doing 4-pair cabling and it's going to be used for power over Ethernet, it's highly recommended that you add that DC resistance unbalance test to that. So that would cover the testing, and that just about wraps up the long distance cabling, the extended distance cabling. And again, your 4-pair extended distance, it's a heavier gauge. It's designed to run, most of these manufacturers will spec it between 150 and 200 meters for running your Ethernet and your power. And again, it's not within the standards, but there are situations that may require it. So it's something to be aware of, something to consider. You may run into it out there, and it's important to understand what it is and understand that you can test it. You just have to use the tests, the limits that are prescribed by that manufacturer. And as I mentioned, they do extensive testing on it. They know what the limit should be in order to support the specific network speeds that they rate it for. And I'm just looking to see if we've got any other questions here. Chuck, if you see anything I missed, feel free to pop it into the chat. Just scrolling through to make sure we didn't miss anybody. When testing Cat6a cable runs, what's the most common reason for failing a next result, and how do you usually troubleshoot it? Okay, good question. So, and we're talking about a Cat6a cable run. If it fails next, which is nearing crosstalk, the most common issue there is going to be a termination issue. The termination, the punch down at the panel or at the field end out at the faceplate, the telecommunications outlet. And how do you troubleshoot it? So most of your testers will have a TDR function on them. When you fail crosstalk, you can go to the TDR function. In our tester, you just go to the details tab, scroll down. It's called Next Locator. You look at that, and you'll see a TDR trace of that cable, and it'll tell you along the cable. It'll show you the spikes where the crosstalk is the worst. You always look at the worst one first. The biggest spike is where you go first. Now that TDR trace will also tell you the pairs involved in that worst case spike. So it might say 3645. You want to look at the blue pair and the green pair, right in those middle 4 pins on that RJ45. So that's typically how you would troubleshoot it. But near and crosstalk, the most common cause is going to be a termination issue. You could also cause it by damaging the cable during a pull if you use too much pulling tension. If the cable's damaged somewhere along the length of the cable, you can also see that in that TDR trace of the near and crosstalk. So that'll help you pinpoint if you do have a mid-span problem with crosstalk because the cable is damaged, it'll show up there as well. So I hope that answers that question. Somebody said, hope you feel better soon, Chuck. Yep, Chuck will be back at it before you know it. Again, I think we're getting close to the bottom of the hour here. I think Chuck wraps up at 6:30. And I would like to thank everyone for attending Let's Talk Cabling tonight. I appreciate you letting me stand in for Chuck. That's some big shoes to fill. And I certainly can't fill them, but I'm doing my best. And I really appreciate that Chuck trusted me enough to reach out and ask me if I could help him out. So again, tune in to the next episode of Let's Talk Cabling. And in the meantime, go on to that Let's Talk Cabling website, go in and support the channel if you haven't already. Again, part of me supporting the channel is part of why I got that challenge coin. So yeah, go in there, do the Patreon thing and support Chuck. And we all hope that Chuck feels better soon. Thanks, everybody. Have a good evening.